Quiz 1. Here's the key. Biggest thing for this one, what I saw, so I had 3-point arrows, trans H to the product. Make sure you grab the right hydrogen. Make sure you grab the trans hydrogen. So it has to be, right, this is an E2 reaction, reactive base. We're making a pi bond, but it has to be the hydrogen that's trans to this chlorine. So that was one thing, the right arrows, but then also grabbing the right hydrogen. That got you to this terminal alkyne, and then the other product was just the protonated nitrogen. That's all I was looking for there. This is, your classic practice, hybridization state. Hybridization state I always box in, and then hybrid orbitals. So let's add lone pairs first. So oxygen has 2, nitrogen has 1, phosphorus has 1. This oxygen is sp2 hybridized because it has lone pairs, it has no pi bonds, but it has lone pairs and it's next to a p orbital, so it chooses to be sp2. This carbon has 2 pi bonds, so it's sp. This nitrogen has 1 pi bond, so it's sp2. This oxygen, because it's sp2, right, it has 2 lone pairs. One of those lone pairs is in a p orbital, so it can do resonance, and the other lone pair is in an sp2 orbital. This nitrogen is sp2 hybridized, has a pi bond, so this lone pair is actually in a sp2 hybrid orbital, not a p orbital, because it's using its p orbital for the pi bond. So this lone pair can't do resonance, right? Only electrons in p orbitals can. This phosphorus has a lone pair, doesn't have any pi bonds, but it's next to a p orbital, so its lone pair it'll choose to be sp2 hybridized and put its lone pair in a p orbital, so then it can do resonance. So yeah, I asked you here, draw the lone pairs. So it's just 2 oxygens, so 4 sets of lone pairs. Star all the sp2 hybridized atoms. What a lot of people forgot, they saw the pi bonds, that was easy, right? They forgot these oxygens were sp2 hybridized because even though they don't have pi bonds, they have lone pairs and they're 1 bond away from a p orbital. So they will want to do resonance, so they choose to be sp2 hybridized. Also, some people goofed up and saw this carbon, right? This carbon has no p orbitals, so it can't do resonance, so it doesn't do anything with this. So those things starred. And then I asked for 2 resonance structures. You could do lots of different things. I just showed 2 examples. These are electron donating groups, right? Like pushing electrons into the ring. So it's starting to think about those things at this point. Arrow goes between 2 atoms, makes a pi bond. Arrow goes to an atom. Electrons go to that atom, has a charge. Make sure you balance your charge when you do these resonance structures. As always.